Okay, let's get started. Excellencies, distinguished delegates, colleagues, welcome. Today we will talk about the present and future role of DAS for NDCs and implications for CTBTO. My name is Ch3. Larsen. I'm from the Danish NDC in Copenhagen, and I will be the moderator for the next hour. I will start by welcoming His Excellency, the Ambassador of Denmark in Vienna, Christian Grønbæk Jensen, who will say a few words of welcome to you. So please.
Thank you very much, Tine, and good morning to all of you, distinguished delegates. It's my pleasure to welcome you to this side event hosted by the Danish NDC and the Danish Embassy in Vienna. I'm very pleased to see all of you, and I hope that you will engage in fruitful discussions on how to improve the abilities of NDCs around the world in important verification work by taking advantage of new technological advances in fiber sensing. Engaging in and applying new technologies has always been important drivers in Denmark. This has helped our society to flourish, and it is our hope that with this event we can highlight some of the advantages of and challenges related to cutting-edge fiber sensing technology in the form of distributed acoustic sensing at NDCs, in IMS and in OSI. By having an open, technologically based discussion with a diverse panel of experts from around the world, we hope to provide food for thought for all of you to bring home to your institutions. And with these words, I will pass back the floor to our moderator, Tine, and wish you all an enjoyable and interesting hour here at the Hofburg. Thank you very much.
Thank you, Ambassador. As our ambassador said, we love high-tech in Denmark. We are a small country with big visions, but we also know as a small country that we need friends, we need people to collaborate with. And that's why we have assembled a panel of experts with widely different backgrounds who will share their visions and illuminate many of the aspects and challenges related to this new technology. So I'll just briefly introduce my panel. So if you will, my panel will please come up on stage and take your seat so you can find your correct name on the on the table. I have so the first out on the side is Ben Dando from the from NORSAR, seismologist from the Norwegian NDC. Then we have Gonzalo Fernandez from the Observatoire San Calixto in Bolivia, the Bolivian NDC. We have Mikael Masur from Nokia Bell Labs in the US, but he's really Swedish. And then we have Emilia Koivisto, Seismic Techniques Officer with OSI here in Vienna, and she's actually Finnish. So we are having quite a Nordic panel here, even though we disguise it as something completely different. So I think we should, instead of me talking all the time, I can do that. But I hope that I'll ask our panel to do their presentations. They have prepared some very small presentations. And in the meantime, I hope that all of you will think of a lot of hard questions, good questions to ask for discussion with our panel. So please, can we have the first presentation for Ben Dando up? And then Ben will say a few words about DAS from his perspective.
Yes, thank you very much for having me. So I thought I would start by just talking a little about NORSAR and our expertise and what motivates us and the kind of our interest in DAS and what we're doing there. So at NORSAR we have over 50 years of experience in seismic array processing. So we're operating 7 seismic arrays at the moment throughout Scandinavia, and we're currently kind of setting up an 8th installation in Antarctica. So we have a kind of a long history of using seismic arrays and for event detection and event classification. and for verification purposes. So DAS is essentially another form of array. So there are clear reasons why we want to use these data to our advantage. So we want to be able to use our expertise that we've already developed on this new technology and kind of push it to its limits and see what can be done. So as I say on the slide, our goal is to kind of test our capabilities, understand the limitations, and develop DAS-specific algorithms, see exactly what it can and can't do. And then on the pictures, I'm showing two examples of infrastructure that we have at NorSAR. So on the top left, you can see we have dug up our garden outside our building, because that's always fun. And we have installed cables there to be able to do certain experiments. We've filled them in with sand and concrete and gravel. And this is kind of a nice experimental area that we have outside our building to be able to do some fun experiments. But we didn't stop there. We kind of went a bit further and decided to go into the Norwegian forest and dig up a much bigger area. So we have in an environmentally friendly way, I must say. So we already have a seismic array there, so the NORES seismic array. And this has currently has an aperture of 1.5 kilometers. So that's shown on the map in the bottom left. These are the orange triangles. They're very small, but the orange triangles are seismic sensors. It's one of our seismic arrays. But the colored arms, these are all new since 2023. These are all fiber optic cables. So we have what we term a DAS array called Norfox. So this is a really great chance to be able to, again, test the limits and try out different algorithms, see what observations we can record, and come up with some neat processing abilities. And we started looking at DAS back in 2017, and actually, and my colleagues at the back are the real drivers in this, actually. And we were looking mainly to do with microseismic monitoring capabilities or applications. But with the new installations, with the observations that we were finding, we immediately saw the application to verification type applications. So this is a big area that we're pursuing at the moment. And these are kind of some of the observations that we're seeing, different applications. So on the left-hand side, it's really demonstrating what we can do in terms of how can we apply traditional seismic array processing to DAS. So you see P seismic and S seismic. Those are observations of an explosion recorded on the NORES seismic array. And then next to that, we have PDAS and SDAS. And these are the observations that we have processed on the Norfox DAS array. And the Norfox DAS array has a bigger aperture, so we get a better kind of resolution, a smaller peak in our FK plot. But you can see we're able to actually do similar processing. What I don't say here, though, is that to get to this, we have to take into account the sensitivity of the cable. So we can't just process it as we would for a seismic array. We have to apply specific weighting on the cables, depending on the direction of the arrival, and then weight it appropriately, and then we can generate these sorts of images. So we do have to think carefully about the specifics of how we're processing these new types of data. In the middle, we're showing kind of an example of the acoustic arrivals that we see on DAS. And this is something that we're really excited about, actually, that we're seeing for the DAS that it's particularly sensitive to picking up acoustic signals. So in this particular case, we're seeing a series of signals from a thunderstorm. So each one of those peaks and each one of those wiggles in the plot is a lightning strike that we can detect on our DAS fiber. And we can scan through it, and we can apply different incoherent beamforming and generate events based on that, and then we can locate them and find out exactly where they're coming from. So in real time, essentially, we can track acoustic signals. So it's showing a real potential there. On the right-hand side, I have an example of what we can do offshore. So there's a cable off the coast of the UK. So in white is the kind of 90 kilometers of cable that we were interrogating. And we have seen examples of earthquakes. We have seen examples of underwater explosions, so detonation of old World War II munitions. And we've even seen an example of an onshore explosion where they tried to defuse a World War II bomb on land, and it accidentally detonated. Safely, I should say. No one was hurt. But you can see in those signals, we are seeing the seismic waves, the body waves, but we're also seeing the hydroacoustic wave, and we're seeing the acoustic wave too, that's traveling through the air and then coming down through the water column and then recorded on the fiber. So it really is kind of a multimodal instrument to be able to detect all these different signal types. So I will finish up here with the opportunities and challenges. I don't know if you want me to go through them, or we can leave this as speaking points.
I think we'll leave those for later, but
Yep.
I will say, why don't you just go through them?
Sure.
I think it's fine. You have not used that much time, so it's
Oh, good. I felt like I was talking a lot. So there are various kind of opportunities and challenges with DAS. So we shouldn't ignore the challenges for sure. So one of the great things is that we can access new areas that we couldn't access before with seismic sensors. So particularly subsea, it's not easy to put out OBSs. It's not easy to get to new places and do a site survey and do all the necessary groundwork to put out a seismic sensor. So there's a clear opportunity there. The fact that we have signals from both seismic, hydroacoustic, and infrasound is really kind of showing the potential, as I said. And it is also an opportunity to develop new things. It's a new data set, and whenever you're presented with kind of new data, then it drives innovation. We can do new algorithms, think about data in a different way, visualization, processing. These are all things that come from being presented with a new data source. And the fact that we're producing so much data volume, which is a challenge actually. How do we store this much data? What do we do with it? It's also an opportunity because we're presented with incredibly dense sampling, which means that we can see the signals on a much higher resolution than we've ever seen before, that you can see with traditional sensors. So again, that is an opportunity. The potential for rapid deployments, so we can quickly go to places where there is existing fiber optic cable, which is almost everywhere, plug in an interrogator, and we have sensing equipment in place. So it's a fantastic opportunity there too. So the SNR, in terms of challenges, is lower than seismic sensors. There's no getting around from that, but we do have a huge number of sensors that kind of partially compensate for that. The data volumes, we need to think about how we store these data. Are we storing continuous data? Are we storing, and are we developing new compression algorithms to deal with this? Or are we just storing segmented data? And then processing integration. How do we take this technology and fit it into our existing our processing pipelines? And I don't think this is unique to DAS, actually. We have this same challenge with infrasound and hydroacoustic and plugging in those results into our event association algorithms. So it is a difficulty, but it's not something that's necessarily new. And then, particularly with subsea, there are challenges associated with accessing all data. Some people do not want us to be sensing the oceans because we might see things that they don't want us to see. So we do have to consider that aspect and think how we can best approach the problem. But yeah, as a key takeaway, I said DAS is not a replacement, but a powerful augmentation. So, and we really need to do some systematic testing of what exactly its role is or should be in verification.
Well, thank you, Ben, for sharing from your vast experiences with DAS. I think it's really interesting how you demonstrate that it's actually a three-in-one, that the not a replacement, as you say, but this can aid both in the seismic work, the infrasound work, and the hydroacoustic work. So it's really a very powerful technique. Could you, before I pass onward, say where, now you outlined a number of opportunities and challenges. Where do you see the greatest need to put in effort right now?
I think really taking advantage of the dense sampling of DAS is where we can kind of get the most gain. And the fact that when you look at seismic sensors and the signals from there and you have an isolated signal, it's always difficult to kind of unravel that. When you're presented with essentially a picture of your signal, you see the move out, and you can immediately understand the signals that you're observing. I think that's where we really need to drive forward and take advantage of those kinds of data.
Great, that's a great message. Thank you very much. I will now pass on the floor to Gonzalo, who will give us some perspectives from another, now I come from a small NDC, from another small NDC in Bolivia, and how do you see DAS could help your work in Bolivia?
Thank you very much. Thank you to all of you for being here in a small NDC in that place. Well, I like to think that we do a convolution process in every day in our life. For example, in the case of my small NDC, we have the seismic, the infrasound, the hydroacoustic, and radionuclide data that comes from the IMS. So we do this convolution in order to detect any nuclear explosion. I always like to think also that we have an N and D process, an AND process, a logic process, that we can integrate any of these data in order to have more experience and in order to have more data to fulfill the CTBTO objective. In that sense, especially in my NDC, we benefit from seismic and infrasound. Saying that, we have this objective to contribute to the seismic hazard assessment. So what can the DIS technology improve in our cases? For example, not only my NDC, but also the academia. As I heard from our colleagues, experts from NORSAR, OSI, and Nokia, they have a long history in that part, which means that we can benefit from this experience to have and to go beyond only to detect any nuclear explosion. In the next slide, I would like to show you, for example, what will happen if we start to merging all these bulletins, the expertise also from the state signatories or the state parties, and also to add the DAS, but taking into account the challenging of that. I mean, as a state party, we are able to contribute with some local data in order to improve and enhance the results to give to our authorities. In that sense, that's why I put the small arrow and I say DIS technology in order to do and to support the academic research and also to help to decision makers. I know that in South America we don't have or we didn't have a lot of nuclear explosion, or we have a small set of explosions, I mean in the inlands, but how can these small seismic events will help, for example, to the artificial intelligence framework to detect and to give some insights and to enhance the system for detecting not fast, but most accurate small seismic events. Sorry for the redundancy. In that sense, seeing the examples that I read in the academia, we can say that all NDC is able to do that. I mean doing from the training, reading the papers, and then giving some feedback to the commission. Of course, and I don't want to be more extensive in that because I don't have so many experience working on that. I work more with the waveforms, but I think that we can have a collaborative DIA system proposal, which means you can imagine a small NDC cannot handle tons of data. In that sense, we can set some small chunks of data being, for example, for the exercises, and we can proceed to integrate that in order to present an enhanced solution. This is all I would like to say because honestly, I don't have a lot of experience on that, but I encourage to all NDCs that use this technology to integrate and to learn from the experts that we have in the room. Thank you.
Thank you, Gonzalo. I think you make some very important points on how difficult it sometimes is for a small NDC to take in all these new technologies. And by suggesting that DAS data is shared among NDCs, I think it will give opportunities to also the smaller NDCs. So do you think it would help you and other small NDCs around the world if, for instance, we had DAS processing software in the NDC in a box? I know this is a very popular piece of software that's shared within this community. Could you see that? Would that help? Or do you see other ways that would be more useful for your NDC?
It's a good question and a good statement. Of course, for small NDCs like mine in South America, if we benefit from NDC in a box, small chunks of data, small tutorial, let's say, small pipelines to process the data, for somehow to integrate our own data, for example, from the Bolivian fiber optic network, will be awesome. That's what we do in our institution. We integrate all the data that comes from different contribution. Even we share data with neighborhood countries. And we learn from that. We learn from the lessons that you have learned in the past, and we implement in our small NDC to produce some benefits for the country, and then also benefits for the society, I think.
Thank you very much. I will now pass on the floor to Mikael from Nokia Bell Lab, who's a fiber sensing expert, and who has some completely different technologies also to share and ideas and what we can do. So please, Michael.
Thank you very much. Oh, let's skip this one. This is useless. And before starting, thank you again for organizing this panel, and special thanks to Denmark and to the Danish embassy for the very nice treats served outside. Particularly for Scandinavians living further away, that's a very nice welcoming. So as I said, I work for Nokia Bell Labs. We're a research fiber sensing system. And after listening to this conference, I thought I'd take a little bit of a different perspective and maybe a little bit of a challenging role to DAS, in the sense to hopefully encourage all of you to leverage the technology, but also optimize the technology for what you try to achieve. So I think DAS is a very misleading name. It came out of an original story behind the first companies involved in implementing it, rather than an active decision to call it DAS. Because as I think most here know, we're really trying to measure distributed fiber optic strain. And as was pointed out, I think, by both previous speakers, one of the reasons we love this technology is that you can put it on any telecommunication network effectively, and you have access to massive amounts of fibers. But it doesn't exclude putting dedicated fibers down, and originally DAS started using dedicated fibers. And I think it's something that we need to remember, that both on the engineering side, in terms of the instrument, in terms of the fibers we deploy, and in terms of the signal we look like, there is a large room for improvements and optimization. It's not a one-size-fits-all, even though there are now maybe 10 or 20 different communities all talking about DAS. Everyone has their own frequency ranges, their own requirements. And I put up two examples here, which are two recent work, one coming out of Caltech and the other one coming out of ETH Zurich, both studying polar regions. In one case, the Caltech team was actually able to leverage infrastructure on the South Pole, where there happened to be a fiber to complement acoustic and other sensors. So they were able to bring a high-performance instrument down, and they decided to leverage an existing telecommunication fiber already present. Similar results to there was actually achieved in the north areas around Greenland by the ETH team, but they purposely deployed fibers. meaning they're in a very different domain. They worked off generators, so for them low power was critical. But they had much more opportunity to actually survey the fiber, decide where to lay the fiber, and make sure that the fiber coupling is sufficient and optimized into the ice. So these are two, in a way, similar studies. But for me as an engineer, they're approached very differently because they have very different constraints. And I think for a community like this, this is essential. And of course, you can do it both passively and actively. So I think what I'm trying to say here is really that, and as pointed out before, I think that is a very powerful technology, but it is a different technology. And it's most of the time a complementary technology, maybe with a few exceptions. What it really gives you is a massive increase in sensor density along its line of any shape or form, which I think has a huge power. From an engineering perspective, I think it's important to remember that one reason why we can use DAS so much now is basically not only innovation in optics, but really innovation in computer architectures and in compute. So we have access to massive compute resources, which kind of means that although we like to say that DAS generates challenging amount of data volumes, and it's hard to store and so on, we hear this all the time, I think it's important to remember that that's really the power of the technology. It is a giant beamforming array. And if we try too much to just make sure we get minimum data out of DAS, we actually lose out of a lot of the potential. And this is not only for the kind of mission of this room, but this is something that has been a general trend throughout all field touching fiber sensing. I mentioned fibers before. Maybe you're all familiar with this, but I think it's an interesting example to mention, for example, that if you put down a sensing fiber, which you could easily do, let's say you use optical fibers to connect a seismic station away, you can directly gain something like 20 dB SNR, which is a factor of 100. So we always mention that DAS has low SNR. It's obviously true. It's nothing like a seismic station. But there are very straightforward ways if you build a system where you can gain back a lot of SNR. If you then were to purposely think about how you actually couple your fiber inside the cable, there is another factor of 10 dB or more to gain. So the reason we're saying this is not to say we shouldn't use the telecom network. I work in the telecom industry. It's a fantastic opportunity. But it's to remember that depending on what we're trying to achieve, there is probably not going to be a one-size solution fit all, neither on the fiber nor on the infrastructure side. And one example of that, which came out of our lab recently, work we do, is also that Ben mentioned the ocean, and we are now developing an instrument that actually pushes the frontier of this, where we take traditional DAS with a reach limit of maybe 50, 100, 150 kilometers, depending on how people count, and we actually push it out in the ocean, starting doing high-resolution distributed measurements, hundreds and thousands of kilometers offshore. And in that case, all the time we talk about it, we again face saying that this is not an array of seismic stations. If you were to put down in 50 or 100 kilometer spacing a permanently powered OBS, you would win. It's just very hard and very expensive to do this. And I think another example then of saying, if we engineer the technology correctly and we understand the application areas, there is a large potential to use both existing and future fiber optic networks to really aid both with the CTBTO mission, but in general aid with our understanding for seismic signals, different sources, and being able to decouple various impairments that might affect stations. So what you're looking at here, without taking too much time, I think the figure all the way to the right is the best. Traditionally, we have worked a lot on per-span interferometric measurements, just trying to get a few data points over the ocean. But we can now zoom in even, this is 600 kilometers out in the Atlantic, 3,200 meters down, roughly, and we now have continuous monitoring with about 100 meter spatial resolution existing out there, sitting and waiting for signals. And I think it's a unique opportunity, because even though it's a lot of engineering involved, just deploying this infrastructure would be very costly and take years if it was flat. So thank you.
Well, thank you, Michael. I think this is a very revolutionary thought coming out of the industry, because some of us think that we are really advanced using DAS, and now you're saying that this is really actually old school, and that the repeaters, that those of us who use DAS, we fear because they stop our signal. You actually use them actively as an asset for getting the measurements way out in the ocean, but on a coarser grid. So you could have the fine grid with a DAS close to the shore, and then you could have a coarser grid using this new technology. Do I understand that correctly?
I think it's absolutely correct. And I mean, as always in these systems, right, it's an SNR trade-off. In our case, we basically build a system that is 150 to 250 units in one. So if you're scared of the normal data volumes, you have to multiply it by a factor of 200. And that means that pushing it to spatial resolutions like a meter is, let's say, less attractive than keeping it slightly higher up. But what I think we're fundamentally trying to do is we're trying to understand application space. And I think the subsea example here, just like the ice example on the last slide, were mainly to illustrate the fact that even though we all talk about DAS as one word, one technology, there's a lot of room to engineer it based on what you're trying to do. And I think what we hit a lot in the telecom is there's a big difference between leveraging existing infrastructure and asking the question, what can we do in the future? And fibers now are the standard means of which we connect everything, but it doesn't mean that we cannot use it as an opportunity to engineer. And I think this is an example on the system side, but it might be a lot of other, for example, a very maybe boring thing, but like how you trench a fiber has a huge implication on the coupling you get. And if you actually use fibers to deploy seismic station, of course you can trench them knowing that you want to use them as sensors. And I think as a community, we need to start think about these things to really understand the full potential of the technology.
And the enormous data amounts, we'll just have to hope that the technological developments will save us, just like they have done before.
Maybe I can comment on it. I should be careful because I work in industry. For us, I don't think we consider it particularly large data volumes compared to the internet. I think it's also important to say that already today, and later result now coming out of the ETH, we're looking at real-time compression of DAS data of about a factor of 100. And DAS is an early technology. We keep all the data because we're researching it. We're trying to understand it. But it's working at 10 kilohertz rates, 1 meter spatial resolution. Most people start by decimating that data. And I think now with a few years of research, we understand much better the signals we're interested in. So yes, it's going to be more data because there are more sensors. But I think it's at least we're looking at the factor of 100 or 1,000 reduction for most applications compared to where we are today as we learn to work with the technology.
Great, thanks. That gives me some hope. I will now leave the floor to Emilia, who will tell us something about how can we and can't we use DAS in OSI.
So first of all, thank you very much for the very timely initiative from our perspective, as you will soon hear. Just a little bit about my background. So in my previous life as a researcher, so in 2016, that was my first encounter with DAS. We had in Finland a project with the mining companies to develop seismic techniques for mining planning and exploration. And then we deployed DAS cable in a borehole, testing it for vertical seismic profiling with very promising results already at the time, with a lot of these same challenges as well as promises as were discussed here. But for example, really the deployment of the cable in the borehole compared to the seismic sensors that you normally need to kind of lower down in several goes and repeat your sources on the surface, in one go you can cover the whole borehole. So just like Mikael was here saying is that I think really like for the specific purpose that you are needing it, then there will be various different types of solutions and questions that you have to consider. But from the on-site inspection perspective, so the 3 dimensions in paragraph 69 of part 2 of the protocol to the treaty, various techniques that can be used during on-site inspection, and 3 of those are seismic techniques. There is passive seismological monitoring for aftershocks that can be applied from the very start of on-site inspection. So the 3 dimensions also timelines for when you can apply these techniques. And then there is resonance seismometry and active seismic surveys that you can apply from start of a continuation period, which is after 25 days, that it can be approved to continue the on-site inspection, that you can then use resonance seismometry and active seismic surveys. Passive seismological monitoring is meant to cover the whole inspection area, which may be up to 1,000 square kilometers. And of course, you want to, as quickly as possible, capture those aftershocks that may occur after the triggering event of the whole on-site inspection. Then resonance seismometry and active seismic surveys are then more focused, like you would by then have narrowed down your areas of interest, and then you would apply techniques for more detailed site characterization, trying to really pinpoint the exact location where you could then ultimately drill. I already touched this topic, but with on-site inspection, we have a range of restrictions that we need to take into account. One of them is the inspection area. To start with, it can be up to 1,000 square kilometers. The maximum duration is 130 days, with all these different stages during which different techniques are allowed. It can be maximum 40 inspectors at the time, covering the whole range of expertise that we need, that the treaty allows us to use this range of techniques. 40 inspectors is really not that much. So having experts for all the techniques, that's always going to be a challenge. Also, the equipment has to be approved beforehand. We cannot just use any equipment. All the equipment, procedures, workflows have to be pre-approved, documented, and followed. And then, of course, there are specific training requirements that the inspectors have to have received to apply these techniques. So overall, there is need for speed with limited time and personnel resources, which, of course, then in that sense makes DAS very attractive idea, thinking that maybe you could then save some resources with deploying DAS instead of the classical seismic sensors. Maybe just some ideas on how the treaty then may constrain the use of DAS from the point of on-site inspections. Just generally, when OSI is requested, the state party who requests OSI may utilize any relevant technical information obtained by national technical means. So reading this, probably DAS data could then also be used if it was available. Also, during an on-site inspection, an inspected state party has the right to provide the inspection team from its national monitoring networks and from other sources data to explain or showcase what they want to explain to the inspection team. So in that sense, it is maybe a possibility that the inspected state party, if they had DAS data, could provide it to the inspection team. Generally, from the point of view of the inspection team, they have to use approved equipment. So then using any pre-existing infrastructure, fiber optic cable infrastructure will immediately pose a problem because it hasn't been pre-approved for the inspection. And maybe with that, for passive seismological monitoring, really covering 1,000 square kilometers, deployment of, well, who is to say that maybe then the mini arrays sometime far in the future could be DAS-based, but I think right now, really, we are using, obviously, seismometers. We're using a mini-array approach consisting of central 3-component seismometer and 3 satellite 1-component seismometers 100 meters away from the central seismometer. That is, it's not foreseen that this could be replaced by DAS anytime soon. What we are actually doing now is that we are having our very first test, DAS test, in 2 weeks from now, field test for on-site inspection, where we are going to be getting our very first experiences with use of DAS for active seismic surveys. These site characterization surveys that are in more narrowed down areas, typically, let's say, up to 2 kilometers by 2 kilometers, deploying then your cable instead of your nodes, that could speed it up. But of course, then the questions we have with sensitivity, also with, we use 3-component geophones as well, and then for some of our resonance seismometry approaches, which could be passive or active, we use really also ambient seismic noise, and we use 3-component seismometer quality sensors. So there is a lot of very specific questions to how to these different approaches DAS is applicable. But really, we've heard so far, that we see the potential, and we really want to be kind of looking into the future, understanding how DAS could be applied. Thank you.
Thank you, Emilia. I think this is very interesting. So while the rest of us are struggling with the technological part of DAS, you also have the 3D part making life difficult. So what I hear you say is that if the inspected state was prepared to provide dark fibers for an on-site inspection, that might be a possibility, but only if the inspected state themselves say, we would like to provide this fiber network for the inspection.
I think that could be a possibility.
So what about OSI offshore?
Yes.
That's difficult with the equipment you are using today. Could DAS be a game changer for that? Because we have all these technologies, and we know that throwing new gear out in the ocean is not that trivial.
Yeah. So far the OSI techniques development has really focused on having OSIs on land. But that is definitely an area of future development if OSIs would happen in like an area like marine environment, offshore conditions. Generally, like I said, the issue really is that the equipment has to be pre-approved, and then there are these possibilities maybe with the inspected state party providing some equipment. But if we are in the international waters, then using really the pre-existing infrastructure, or more generally, there is a lot of problems with that. But I think personally, I am thinking that really like deploying the cable on the seafloor for many of these seismic techniques done by the inspection team with pre-approved equipment that has been tested and approved for the use sometime in the future, that sounds like it could be an option.
Thank you. Well, I would like to thank our panel for their introduction, and we will now move on to the questions, and I hope many of you will ask a lot of questions. I already have the first question from online, so I think I'll just jump at that. An anonymous online viewer writes, for IMS hydroacoustic stations, would it be possible to use fiber optic cables used to transmit the data to shores as DAS sensors as well? So using this in multiple ways. I'm thinking, Ben, you might be the one who has the first take on this one, and the others can chip in.
Sure. Yeah, I think that's a fantastic idea. The cables are already there, so it's just about accessibility. So as long as we have the means to be able to plug in, then absolutely we can look at we can take advantage of that technology, use it for sensing for events close to the hydroacoustic stations. But in addition, we can use it as a means to safeguard or for state of health monitoring for the hydroacoustic stations. So we can be monitoring if there are any events such as subsea landslides that could take place. These would be detected on the DAS systems. So it actually has multiple uses with respect to the hydroacoustic stations.
So in the same way that many electrical companies, at least in some parts of the world, are already deploying DAS along their high power lines to monitor state of health. So this could serve actually multiple purposes, just like the reader, the online participant writes, use it as sensing, but also use it as state of health and use it for transmitting the data.
Exactly, yeah.
So, Mikael, do you have any further to say on this, perhaps?
No, I can just comment and say I think this has been shown over very similar infrastructure quite a few times. And if you, with the right DAS interrogator, you can sit right next to the data carrying channels that carry the sensor data. So without too much knowledge of the details of the specific IMS network, similar demonstrations, even over fibers to hydrophones, have been showed, and it works really, really well, at least until the last part where it's free hanging in the water. So.
Great, thanks. So, yeah, if you will go to one of them, there's a microphone on its way.
Yeah, just a detailed follow-up, Emilia. If somebody were to show up with a cable that isn't a pre-existing one rolled up on a wheel and connected to an interrogator and say, here's your new underwater sensor. What's the process of getting that approved for OSI used, or for RSI use? Because I've noticed that sometimes those approvals can take time.
So if this happened during an on-site inspection, it's a no-go. But essentially, that's what our techniques development process is about. So we will, the testing and validation cycle kind of goes from field testing to really choosing and comparing, and of course, in the context of the 3D constraints, understanding that how we can apply these techniques, what's the best hardware, software, what sort of workflows can we apply to really meet the mandate or the purpose that we should be using these techniques for. And then really it has to go through, we have to develop our quality management system documentation to have these approved workflows, procedures to use this type of equipment, train our surrogate inspector, after which then, and of course then we also have, OSI has something called the equipment list that we need to be preparing for the entry into force. So at the same time, while that is being prepared, we need to make sure that in the negotiations of getting it ready, that we are kind of having the specifications with an eye on the technologies that really we are planning to use. So there are like multiple layers for the approvals. But at this point, really, like the testing is kind of where it all starts to, and that's what we are trying to do now in 2 weeks, start our very first steps of testing. I imagine this will be a long process, but just to get some initial experience in the OSI context. Thank you.
Great question and great answer. And I'm thinking along those lines that we are seeing DAS being used on a lot of old fiber infrastructure, and it actually works quite well. So once you get a cable approved, it will probably be good to go for the next couple of decades. So it's the interrogator that's more the challenge when it comes to that. So do we have more questions from the room? Yes? No? Yes? Is the microphone coming?
Thank you. This is a question for the experts. I understand that there is a saturation issue on the amplitude of the signals that you can measure. So there is a certain point that you can no longer reliable record a waveform signal, let's say, after. And the other question is whether you think that tsunamis can be tracked with these underwater stables. These are two questions.
Maybe I can try to answer. I think it's an excellent question, and it's being reported a lot. So the problem of saturation is a little bit special, and it's mainly related to the settings you have and you use your instruments for. So it's kind of an analog to how modern seismic stations use different instruments, and when one instrument saturates, you have another instrument to take the high signals. So with DAS, it's very similar, but we only typically today record one parameter. And most of the times we tune it to get the best sensitivity, which means that it saturates. But from a signal processing perspective, and we do this all the time, you can do multiple parallel processing on the problem, and then you can actually extract it. You have sensitivity basically up until you have plastic deformation of your fibers. But at that point, normally you have other problems than... When it comes to the tsunamis, it's a very active, ongoing thing. What I think we can say, and this has mainly been reported from Japan, so I don't know if anyone from Jamstack or associate organization in the room, they do observe tsunamis on the fiber coming into land. So we know that DAS can detect tsunamis. I think it's in an early stage, and it's not yet to the point that we have enough studies. I mean, fortunately, there are not that many tsunamis that would be detected around the globe to say how it scales. It is today quite often also connected to somewhat of the reach limitation. So we have a typical DAS, neglecting the ones I showed, we're talking maybe 100 kilometers. But I mean, that is from the point of the interrogator. Most subsea cables tend to have maybe up to 10 kilometers on land. Then they go in shallow water. So I think there's a lot of very exciting work happening right now about understanding this. But we know we can see them. The potential for leveraging this for example, global tsunami early warning, I think is unknown, but it's actively investigated.
Thank you. Thank you very much. Good question, good answer. We have an NDC question. So how might NDCs best use DAS in real life? Would it be as to complement existing networks, existing data? Would it be for redundancy? How do we go about it, especially for the smaller NDCs with the large data amounts? Do we need some? Now we had an AI day the other day. Are we going for deep learning? How do we do this best?
Well, for the small NDCs, let me be honest with you. We integrate all the data. We like I said, the convolution data. But we work with small chunks of data. We cannot work with the tons of data despite of in artificial intelligence, the trend that we have. However, let me imagine that we have an infrasound network, let's say. What will happen if we put a DAA system to the infrasound and we combine with a small short period sensors with one component? And with the DAS, we'll try to improve some teleseismic events. For example, in our case, from the Chile or Peru, that they are highly seismic events. So I think this can be an opportunity to develop the skills, but also to improve the methods to work with a small chunk of data for specific events. In our case, for example, so sorry for extending my answer, is La Paz is located in the Altiplano. So we're affected, one example, with faraway seismic sources. An earthquake, for example, of Chile, like Professor Barrientos is here, we have a gap in Chile. If we have a magnitude 8 in the northern part of Chile, La Paz, my city, will be affected. How can we record that? How can we improve the processing of that data? How can we collect that data in order to work in seismic hazard assessment? So I think this is a great opportunity if we work with a small chunk of data using the trend of artificial intelligence, of course, but I think integrating is a solution for small NDCs.
So integration is the key. So what do the larger NDC on your right side think of that?
Yes, I think from our point of view that how we would like to use DAS in the future is really an augmentation of what we already have. So be able to go to places where we have not been before, so subsea, places that have been inaccessible, and really enhance the network that we already have. But then in addition to that, I think it's going to greatly help in terms of being able to interpret signals of interest. So again, this idea of this dense sampling, it's going to quickly enable us to be able to understand signals that were a lot more difficult and a lot more time-consuming to go through and analyze before, because we have that dense sampling of the wave field. And there's some kind of parallels to the tsunami monitoring, for example. When you're seeing the wave field cross across the DAS array, and you're sampling the wave field in such high resolution, then there's so much you can do with it. And in addition, that we have something that we haven't talked about is modeling. We can model the wave fields and what it would look like on the DAS, and that's going to help us further in the future. So it really is a kind of strong supplementary technology that we can use to our advantage.
So do I understand you correctly when you say that this will also help in the discrimination between explosions and earthquakes, incorporating DAS data?
I would hope so, yes.
But we're still not there.
Not there yet.
Yeah. Okay, great. Microphone coming.
Thank you. Angelo Strollo from GFZ. First of all, thanks for putting together this fantastic panel and for the nice discussion. I would have a comment and a suggestion. So the comment is that it is clear that we have on one side the technology and the application, the use cases, and we are in a sort of a loop, because the technology needs use cases to develop and needs understanding of the applications and so on. And on the side of the applications, we are in this loop that we need to understand better the technology and to use more data. So based on that, and this was also mentioned by the panelists before, I think really the key and the effort in the coming few months or year should be on trying to make sure that we can really exploit the data in an easy way. So to make data available in a way that they are understandable, they can be used in existing workflows and so on, that we can boost this interaction between the applications and the technology development. And one example, for example, that goes back to the small NDCs and to the applications are these type of things like plugins for existing softwares that they solve also a number of things on the fantastic table that was showed before, where a number of challenges are related. So the augmentation and the processing of dense channels, it solves the problem if it's done on the interrogator itself, because you reduce bandwidth that you have to use, you reduce data volume, and of course you improve also the signal-to-noise ratio. So all these things, they can really be boosted if we all do an effort in starting to use data, or do efforts in making the data interoperable and easy to use.
Can I say? I 100% agree with you. Just now, NorSAR is also here in the panel. In general, maybe everyone is aware, but was it 2 years ago? There was an effort that we were not involved in at all. I just really appreciate that they did it, which is called the Global DAS Month, where they had multiple interrogators all around the world recording at the same time, including the big devastating earthquake in Turkey. And that one is public. And at least both for the upcoming AGU meeting and the last SSA, there was a remarkable effort to developing open source software on GitHub that basically just pulls that. And there is multiple different vendors, so all these kind of compatibility problems and so on, they largely worked out. So I think I fully agree with you. I think it's absolutely essential. But I think it's also really encouraging to see the huge effort that is being pulled by largely academics, I would say, at the moment. Industry has very little to do with it. But so if anyone is interested in a big data set, I would check out the Global DAS Month. You can just put it into Google Scholar and it will show up.
So data are available and software is becoming available on GitHub. It may still be a challenge for some of the smaller NDCs not having enormous resources, just being a few people. So I think on my own account, I would say we still need better tools, easier tools to use and integrate the DAS data. So, yeah.
Can I jump in as well?
Yeah, please.
I just wanted to add to that. Yeah, I'm fully supportive of developing more open data sets and allowing people to become more hands-on with the data. I think that's the way forward, because we don't have access to the data so much, and we don't have access to, not everyone has access to an interrogator. And for example, the infrastructure that we have at NorSAR, we don't want to hog that for ourselves. So people are welcome to come and use our equipment and to try things out and collect their own data sets. I think this will really benefit the community as a whole, which is ultimately what we want to do.
Great. So I think time is flying in good company. We only have 2.5 minutes left. So I'm wondering if we can ask each from our panel if you have some takeaway from this discussion, something you think is important for all of us to bring with us when we leave this room. Emilia, have you thought of something that's particularly briefly relevant for DAS and OSI?
Well, there were actually very many takeaways. I think these types of discussions are very important, because then you just look at this from your narrow angle and then you don't realize really what all is going on in the world. So I think we can really learn from all the experiences and then try to apply them to our specific context, which will then clearly always require very specific questions to be asked, how to do DAS best in your specific context and for your specific application.
Thank you, Emilia. Mikael, do you have something?
There's a lot, as was pointed out. I think in general, it's very encouraging for me to see all the different areas that are looking into fiber sensing and looking into DAS. I think it's clear that the challenge remains that the seismology community kind of pioneered a very, very nice openness in terms of both data, methods, and others. And I'm hopeful to see fiber sensing becoming part of that. Maybe what we need is massive cloud infrastructure. I don't know. But I think and hope that that will happen, and hopefully that would help a lot.
Great, thanks. And Gonzalo?
Once again, thank you a lot for being here. Thank you for the invitation. And I think it's a challenging time, and I think we cannot have the right to exclude any technology. So we need to integrate all this technology to enhance the answers and to learn from each other. GitHub and open sources are a great way to learn and a great way to experience with many things. So once again, thank you and let's keep improving ourselves in knowledge.
Thank you. And Ben, you have 30 seconds.
Okay. I would just say, don't be put off by the challenges. Keep them in mind, but focus more on the opportunities that DAS presents and what can be presented there. It's very easy to get stuck in the rut for new technologies and think about all the negatives, but actually think about the fantastic opportunities. I think that's where I would leave things.
Great. Thank you very much. I would like, on behalf of the Danish Embassy in Vienna and on behalf of the Danish NDC, to thank this amazing panel we've had today, and thank all of you for showing up and the online participants for asking questions. I'm sorry I didn't get to all of them. While you applaud our amazing panel, I will give you a small gift that should remind you in the coming months that, yes, we should continue working towards this.